Um, 11.3 maxima and minima problem. We did this one in the calculus. For example, if we have an equation like x square plus 5x plus 6, and we want to find the minimum and the minimum maximums. So what do we do? So first of all, we will make dy by dx equal to 0, and we will find the stationary point. Then we will check this stationary point, whether it is minimum or maximum, by checking two one ways: the ds square over dy square over dx square is greater than 0. This is a minimum, and d square y over dx square less than 0, then it is a maximum. So this is one way of looking at it. The second way is we have to study the gradient. So assume we have one stationary point x equal a. Then we are studying this one gradient. Uh, this is x equal a. Then x less than a and x greater than a. Then if we found out uh, gradient is dy by dx like this, then this is going to be a maximum. If we find the gradient something like this, so it is a minimum. So initially this is increasing gradient, then 0 and a negative gradient, positive, 0, negative. This is maximum. Negative, 0, positive. This is minimum. So both ways. If this case is failed, then we have to refer to this method. There are situations that the case is failed. So we'll find for this one dy over dx equal, this is 2x plus 5. Then make it to equal to 0. Then 2x plus 5 equals 0. X equal minus 5 divided by 2. Now we need to know that this value is a minimum or maximum. So then we'll take double differentiation. So d square y over dx square, I'll check the first method. Then this is going to be simply 2 greater than 0. We don't need to apply this value. It is a minimum. So we found out x equal minus 5 by 2 minimum. Or this is the gradient, you want to check the gradient. So we'll like this, x equal minus 5 by 2 and x less than minus 5 by 2 and x greater than minus 5 by 2. So this is 0, this is 0, and we know this is going to be, when you put any value less than minus 5.2 for this value gradient, we will get a negative, and any value greater than minus 5 by 2, even 0, when you put, this is positive. So this is the second way you can work out. So this is maxima, minima. This is the revision of the differentiation. So we are going to apply to this section now. Discuss example 5 now. Example number 5, traveling distance of yo-yo is given by this equation. Part 1, justify the restriction. So we need to, there's a restriction 0 greater than t greater than 3. So we have to justify. So this is a distance. First of all, we'll find the root of this equation. And we know this is going to be a quadratic cubic equation. You know how to draw a cubic. However, first of all, we'll find the roots of this one. To find roots, uh, let s equal 0, then 0.60 plus 0.40 square to cube is 0. So I can multiply by everything by minus 2, minus 10. So then this is become positive 2t cube plus 0 4t square plus 60 equals 0. So t cube 2t square plus 3t equals 0. When I factorize t square plus 2t plus 3 equals 0. So this is t and this is t plus 1 and t plus 2. Something wrong, we have to look at it this. Those two are negatives. This is negative and this is negative, negative and negative. Then this is going to be 3 and minus 3 and plus 1 equals 0. Then t equals 0, t equal minus 1, no, t equal 3. So t has to be greater than or equal to 0. Hence t equals 0 and t equals 3. So those are the restrictions. Now we have two options. One option is 0 greater than t greater than 3. Then other one is 3 greater than t greater than 3. So we have to show that this is failing. When you draw this graph, you can see this is in the example t and v. Since this is distance s, the this after from this point, so this is 0, this is 3, this is minus 1. We're not going to discuss this. It has to be greater than t 0, and we are not going to discuss greater than t greater than 3 as a distance is going to be negative. When t greater than 3, s is negative. Hence model is valid when 0 greater than t greater than 3. Part B is we need to find the maximum distance. When you look at this curve, we can see that this is going to be the max. So as usual, we will find ds over dt, make it equal to find the maximum t, or equal 0 to find t for max s. So we'll differentiate this one now. S equals 0.6 plus 0.8t minus 0.6t square, and then we have to make so this is ds over dt. We have to make it equal to 0. ds over dt equals 0. Then this is multiplied by I will multiply by 6, 10. Then 6 plus 80 minus 60 square equals 0. So 60 square I can divide by 2. 2, 3 plus 40 minus 3t square equals 0. So again I can rewrite 3t square minus 40 minus 3 equal 0. Now we have to use t equal minus b minus 4 plus or minus b square minus 4 square minus 4a minus 3 times 2 times 3. So t equal, you will get two answers, 4 plus or minus square root 50 over 6, and one answer is negative, another one is positive. So t equal to option we have 1.8685, or the other one is minus 0.5351. So this is the relevant t value we need. Then we'll substitute to here. So when t equal 1.8685 equal 0.6 1.8685 plus 0.4 1.8685 minus 0.1.8685 cube, and then answer is 1.2129, so approximately 1.2 meter. You can check the example in the book. And now we'll discuss exercise 11C.